Yeah, hello again, everybody. So I'll briefly go over the demos that we have prepared for you to see in the next room. So first, I just want to highlight that why we've come up with these demos. So one is that we want to showcase the different sort of hardware that we have at CIVIT and the software capabilities as well. And we also want these demos to serve as starting points to have discussions of possible ideas and collaborations. So these are the demos that we've prepared, and I'll be going through them. So the first one is about depth map super resolution, which we want to use for depth visualization for teleoperating machines. So I guess many of you have seen in the previous slides about depth sensor. So this is the depth map that you get from a depth sensor. And you can see here like various images, various objects in this depth camera, which is attached on an autonomous vehicle. So you can see a couple of people and different cars as well, and at different distances from the autonomous vehicle. And the depth is represented as a color, and you can see the distances of these objects then from the camera. And at CIVIT, we have various sorts of depth sensors which can be used to sense various distances. Here we've shown how a depth map can be used for teleoperation. So there's this paper which has been studying whether if we overlay depth on a color image, does it help for teleoperation? And what they found out that it really helps the teleoperators to understand when the arm is close to the object. So that's the critical time when they need that information. And in that case, it helps to overlay that depth information. So here you can see like the depth map is overlaid as a heat map. I'll show that again. And so one of the reasons why we need to do a depth map super resolution is that the depth map that comes from commonly used cameras is very small in comparison to expensive high resolution depth sensors. So that's why we need to come up with a solution to handle this problem. So what we've done is that we've used a depth map super resolution algorithm, which works on any depth camera, and it's based on deep learning, and it supports like 2 times, 4 times, 8 times, and 16 times super resolution. And what we've done is that, what we could do is like we could use a higher resolution color camera and then take a lower resolution depth map and increase its resolution and then overlay it on top. So you can actually come to our demo down there, and you can, here in this example, you can see that my hand is in front, and then it's shown in red in the overlay. So another demo that we have for heavy machinery is multimodal fusion. And like this is one of the some of the problems that we face as engineers and software developers is like how do we make the algorithms faster, or how do we make it run on hardware? So one idea that we can use is to combine different modalities and make it robust to different scenarios. So in the demo that we have, we're comparing just using color camera versus when you combine color cameras with depth sensors. Is there any advantage of that, or does the combination have any problems? So you can actually come to the demo and test the algorithm yourself. Like, is it able to segment properly if we just use color cameras, or is it able to segment well if we use the combination? So you're welcome to try out this demo. And these are a couple of other examples to showcase how you can do multimodal fusion. So one common example in autonomous vehicle domain is combining color camera with LiDAR information. So color camera works really well when you have far away objects, which LiDAR cannot capture because it's a bit sparse. Whereas color cameras don't work well when there's low illumination, but LiDARs can still capture that. So what we're doing is we're combining modalities to address these limitations in sensors. Another interesting example is using thermal along with the color images. So thermal sensors can be used for segmenting the salient object when you have a lot of visual clutter or low illumination. So it works really well. And at CIVIT, we have various sorts of sensors that you can try, and you can find out which sort of modalities work well for your problem. Another demo that we have is about camera tracking, which is for the creative industry. So match moving is a technique where you want to augment a virtual object into the scene so that it moves along with the background objects. And normally what happens in the industry is that you use a software like Adobe After Effects. So in this software, what users do is that there are these features which are being tracked across time. So you can see like these yellow tracks that appear there. So the users need to check the quality of these tracks. If there are any bad ones, you remove them or you add new ones. And so essentially what you want to make sure is that the object is being augmented in the proper location and angle. So what happens then is that it's sort of like a cognitive load. First, you need to shoot it, then you need to check if the augmentation works. And if it doesn't work or it doesn't look good, you got to redo the entire shoot. And in order to address this problem, we've come up with a real-time match moving demo, which is run on Z camera. Z camera is a stereo camera, and we're using the color, depth, and IMU information from that to do camera tracking. And then we have the interface built on Unity and shaders. And our match moving software is fast and it supports moving objects. So if you're moving in front of the camera, the virtual object doesn't move. And it supports occlusion. So I could be standing and occluding the virtual object, or I can stand behind it. And we also have a couple of demos related to Volumetric Capture Studio. Before I show you the demos that we have, I just want to go through the sort of services we provide. So we allow you to rent the studio with the option of having technical assistance, and we provide you guidelines, which give you examples of how you can prepare for the shoot, and then we help you to create demos of website 3D, AR, and VR. We also have a list of recommended companies that will work with us to produce high-quality virtual production demos. And also, I'd like to mention that we are looking for pilot use cases. So the first demo that we have is this website 3D and augmented reality demo. And this works on the phone. It works for most phones, so there might be issues here and there. But yeah, you can take out your phones and you can scan this QR code, and you will see Oliver from Sense of Space talking about CIVIT. Yeah, so I hope you all got a chance to open the demo. If not, I can show the QR code again later on. So now we can move to the final demo that you will also see live here in this room. It's about HoloPresence, which is the future of 3D video calling and conferencing. So in comparison to just streaming a person in 2D and just limited to the face, here we're streaming a person in real size and lifelike and in real time. And this improves the communication because you can see the body language, and it improves the impact. And in this demo, we will see Atanas entering the ring, and then he'll be streamed to ChatXR.
Okay. Hello again from our ring or our XR chat room. So I hope you are seeing me sharply in the auditorium. I think I have to remove the glasses because we are suggested not to wear glasses when being here because they are difficult to detect and reconstruct. Yeah, and soon I'm going to speak to someone here in the same room. But before that, let me repeat some of the things that we are aiming at. So we would like to interact and to work with colleagues from various fields, from creative industries or work machines, and to get involved in their problems and to try to help solving them with the help of immersive imaging. It is only our imagination which can help to make things more attractive or more effective or more productive. We are broadcasting from Tampere, Finland, but we can be elsewhere in the universe or metaverse, grace to the emerging immersive visual technologies. At CIVIT, we strive for offering state-of-the-art, emerging, most modern equipment in the sectors of 3D sensing and content creation, representation of 3D visual data, and immersive displays. What differentiates us from other research labs is our strong commitment to establishing long-term relationships with stakeholders, being academic research communities or talented students or innovative companies. We are looking forward for establishing new or strengthening the existing collaborative networks. So let's stay in touch. And this brings our presentation, our morning session to an end. You're invited to step by the CIVIT premises, the next door, grab your lunch bucket and come to grill our demoers. So the call is for interaction. Welcome.